Newton's law of cooling. With this project, our objective is to determine if this law, which states that the state of change of the temperature of an object is proportional to the difference between its own temperature and the ambient temperature, can be applied in normal life situations. We baked a cake to test this. We started by baking it, and by the time we took it out of the oven, we measured its temperature on Celsius measurements, for future reference. Later, after 5, 10, and 15 minutes, we measured the temperature again on an ambient temperature of 28.6 degrees. This was the results. An ambient temperature of 28.6 Celsius, a temperature from the beginning of the oven of 91.3 Celsius, a temperature after 5 minutes of 67.1 Celsius, a temperature after 10 minutes of 68.2 Celsius, and a temperature after 15 minutes of 58.4 Celsius. We used Newton's law of cooling, calculus, and our integration knowledge to see if the function we created according to the law and data from the thermostat could get the same results measured earlier from the cake directly. Our results were a temperature after 5 minutes of 58.4 Celsius and a temperature after 15 minutes of 35.21 Celsius. As you can see, the final results were not the same as the ones calculated on our thermostat the moment it took contact with the cake. This could be because of either two situations. First, a wrong room temperature, or possible error of calculation by the thermostat in the cake between the minutes of 5 and 10. Either way, even if both results have a very high difference, because the equation actually works on other examples, and it marks a lower temperature than the one originally marked, we determined that the equation is successful in a way, and probably more valid than the thermostat, since the values continue going down as time passed on, just as stated in the Newton's law of cooling.